Hello and welcome to our presentation about ATDx tool as submitted to the ECSA 2021 conference. The first thing that comes to our mind when thinking about the ATDx tool, right, is what is the ATDx tool? The ATDx tool implements the ATDx analysis, allowing to execute the approach in a fully automated fashion. So what is the ATDx analysis, right? ATDx analysis is a data-driven approach that, by leveraging the severity calculations of pre-computed architectural violations and severity aggregations into different ATD architectural technical depth dimensions, provides an overview of the architectural technical depth present in a software-intensive system. These pre-computed architectural violations can be computed with the help of different analysis tools, such as Arcan, SonarCloud, or Designite. Now, regarding the architecture and implementation of the ATDx tool, it is important to resemble the fact that, as can be seen in the image, there are two different containers, the ATDx and the Flask server. This is due to the fact that the tool can be run either locally or as a server with a webhook integration. So this means that whenever an event occurs in the GitHub repository, the server will receive a notification and respond with a GitHub comment with the ATDx results. In addition, this tool is designed in a plugged-in fashion, allowing to plug in different tools and generation methods, while delegating the interface to the factory components, in this case analysis tool factory and report generation factory. This also gives this tool focused on extensibility, because the way these three components work is with the use of the portfolio data. The analysis tool would set the object for the ATDx core, and then the ATDx core would set it up for the report generator. Regarding the environment, we have two different configuration files and two input files. In the main configuration file, we would define the analysis tool to be used in the run, during the run, and the location of other input data. The other configuration file is the report generation configuration. In this one, you can customize the report generation and, if required, in what GitHub to store it. Here is an example of the triple, which is one of the input files. We can see that the Java 2975 rule is associated to the granularity level classes and two different dimensions called inherence and GVMS. This piece of information is used by ATDx core to process the raw input contained in the ATDx data file. Regarding the execution, in the case that we run the server, ATDx waits for an event to happen on a GitHub repository. In most cases, it is a pull request. Executes the analysis and automatically returns the ATDx result in the form of a GitHub comment. Regarding the web server, I already have my server set up for this. As you can see here, I'm accessing a different machine with a public IP address. In addition, I already gave permission to the server to make comments. So the very first thing that we need to do in order to run the server is to run the Flask server script. So we need to type Python 3 flask server.py. Once this is done, we need to access this URL and we need to add login to it. That way we will log into the server. Once this is done, in my case, it only displays the homepage of the server. However, it can happen that it will redirect you to a GitHub page that will ask you to grant access to this tool in order to make comments into your repositories. Once this is done, as you can see, for example, right now I just closed the pull request and nothing happened. However, if, for example, I open it, which is the only case in which this execution will get triggered, the execution finishes and then we get the comment in the GitHub. This comment would look something like this. It will have the ATDx value at the very beginning of it, and then it will have a radar chart regarding all of the different dimension values. In addition to this, there will also be a link for the real report. So if we click on it, we'll see that the very first thing that we see is the ATDx. There will be a definition of the ATDx. There will be a description about the different dimensions that we've used. And then the very last thing that we'll see is the ATDx value, the radar chart that we've seen before, and also the top classes with architectural technical depth. All in all, this tool offers the user full authority over the execution of the analysis, with the vast majority of the configurations that can be made. In addition, this tool focuses on being extensible, with the help of the factory class design pattern and the use of the coupling between classes. Finally, users can also tune the tool according to their specific context, and we welcome contributors to refine and extend the tool.